6C, an architectural feature has water overflowing the horizontal diameter. So horizontal diameter means that the circle has to be drawn this way. This is our horizontal diameter here off its semicircular end. So the semicircle that we're talking about is this guy right here. If the radius is 2 meters, so the radius here is 2 meters, what is the force exerted by the water on the semicircular end? So what it's saying is this is the surface, this horizontal diameter. Water is overflowing here, and we're trying to find the fluid pressure on this semicircular end, all of this here. So in order to do that, we need the equation of a circle, which is x squared plus y squared equals the radius squared, which in our case is 2, so that's 2 squared. So writing our integral as before, our fluid pressure integral, we're integrating from a to b. We need, again, a function. L needs to be a function of y. Notice L is the full width, I guess, of this element, dh here. And then we need h as a function of y as well. And we're integrating with respect to dy. So that means we're integrating up. Okay, so Ly then, notice L, because of symmetry here, this is split right in two. This piece equals the length of this piece. So L is actually equal to 2 times x, because that's x is our distance from the y-axis outward. Okay, so the thing is now, we're really dealing with this function y here equals negative root 4 minus x squared, which is, if you think about it, that is just this equation up here solve for y with the negative in front of it when you take the square root, because it's in the negative quadrant here. Okay, so therefore if we take this expression and solve it for x, because our length needs to be in terms of its 2 times x, then we can get our x in terms of y. Then we have a function L of y. So x then, if we rearrange that, it's 4 minus y squared to the half, right? So instead of using the square root, I used the half, right? So I just took either this equation or this one and rearranged it for x, and that's what I got here. Now, h of y, the depth, is negative y. Now, why is that? Well, remember, this is the surface of the water, and the depth would be calculated or measured, I guess, from here downward, but that's just our negative y, because y is the distance upward, right? Y is always the upward distance, so therefore minus y would give you the distance down from the x-axis there. And W, as always, is 9.8 kilonewtons per meters cubed, because we're dealing with water. So we substitute these values in, get 9.8 here. Ly is 2 times 4 minus y squared all to the half, and then h of y is negative y, and here's our dy. Okay, so the limits of integration, because we're integrating y, we need to go from bottom up, so we're starting at negative 2, and we're integrating up to y equals 0, which is the x-axis here. So that's our integration. Now notice this is negative y. So what I've done here is actually I've switched the order of integration, because remember, you can do that when there's a negative quantity here. So getting rid of this negative y, you can do that by just switching the order of integration here. So we had to go from 0 up to negative 2, or I guess in this case down to negative 2. But in any case, then I've written 2y dy together in this. And the reason I did that is because we need to do some u substitution here. So we let u equals 4 minus y squared, therefore du dy is negative 2y, which means du is actually negative 2y dy, and then negative du actually then is equal, if we just switch that negative sign here, is actually equal to 2y dy. So I've written it like that because the 2y dy matches with the 2y dy here. So we just replace that and call that negative du. Then we have to replace the 4 minus y squared with u. And finally, then I guess we need to change the limits of integration here. So the 0 becomes, well, we stick this into y equals u equals 4 minus y squared, and we get 4 minus 0 squared, so that's 4. Doing the same thing with negative 2, we get a u limit of integration of 0. So I write this, then instead of going from 0 to negative 2, we're going from 4 to 0 here. But, as before, we have a negative du here. So what that means, I can get rid of that if I just switch the order of integration. So instead of going from 4 to 0, I'm going to go from 0 to 4, and that takes care of that negative. Okay, so after that, then it's just a very simple integration here. U to the half is u to the 3 over 2 divided by 3 over 2, which we can write that fraction as 2/3 here, and integrating from 0 to 4. And as always, we don't really need to substitute in the 0 here because 0 contributes nothing here, so we just substitute in the 4, and we get 4 to the 3 over 2 times 2/3, which is 16 over 3, times your 9.8, and that is your 52.3 kilonewtons.